Does Wigner's friend support consciousness-first physics? Schrödinger's cat is a reductio ad absurdum. So too is Wigner's friend. Both are related examples of thought experiments which were designed to show how and why a particular position or theory is absurd. 1. Schrödinger on the collapse of the wave function, Schrödinger's many worlds, Schrödinger's scientific realism, 4. Hugh Everett's many worlds, and Wigner's friend. 5. Some technical details. 6. Carlo Rovelli on Wigner's friend. 7. Michio Kaku on observers versus cameras. Schrödinger on the collapse of the wave function. The Austrian physicist Erwin Schrödinger 1887 to 1961 pointed out something which has now become commonplace, that there's nothing in the or a wave function itself about its own collapse. Way back in 1927, it was Werner Heisenberg who first used this idea to explain why physicists only find a single, to use Schrödinger's own word, alternative at the end of an experiment. In other words, experimenters never observe a quantum superposition of alternative states. Yet Schrödinger himself reacted against Heisenberg's notion of the collapse of the wave function by what the former called the observer. In a paper published in 1952, Are There Quantum Jumps? Schrödinger went further when he stated that it's patently absurd that the wave function should be controlled in two entirely different ways, at times by the wave equation, but occasionally by direct interference of the observer, not controlled by the wave equation. From this passage alone, it can be seen that there's a strong hint at the issue which the Wigner's friend thought experiment itself tackles. This is particularly true of the clause, the observer is not controlled by the wave equation, to explain. The physicist has the option of collapsing the wave function, and only then is the possibility or reality of so many mutually contradictory alternatives existing together no longer a problem. In other words, the collapse brings to an end all those alternatives existing together. Except that this issue isn't really solved at all, at least not philosophically. That's simply because we've moved away from one problematic situation. That is the wave function's many alternatives existing together, before its collapse, to another problematic situation that is the actual collapse of the wave function into a single state. To state the obvious, there wouldn't even be any collapse of the wave function if there wasn't a previous wave function which needed to be collapsed. Yet on Schrödinger's, possibly, lunatic multiple alternatives version, the wave function isn't collapsed at all. Instead, one single, in this case at least, cat must be both dead and alive. Schrödinger's many worlds. It must be stressed here that Schrödinger certainly didn't put any of the above in the way I've just done. Instead, he simply raised the possibility that all the wave function's alternatives happen simultaneously. That is, if seen only in accordance with the mathematics of the wave function itself. And this, then, must also be true of all the quantum objects which are part of or described by each wave function. See my Erwin Schrödinger on the many worlds of the wave function. Schrödinger gets to use the cliché weirder. He actually said that all the probabilities in the wave function may not be alternatives, but all really happen simultaneously. Well, according to the wave function, they actually do all happen simultaneously. Or do they? It depends. In any case, the issue here can be summed up technically and philosophically by saying that the mathematical probabilities, or probability amplitudes, of the wave function are effectively concretized or reified by quantum interpreters when they assign physical phenomena to what the math says. Alternatively, perhaps it can be said that the wave function itself concretizes all its probabilities or Schrödinger's alternatives. To repeat, it can basically, as well as accurately, be said that with the wave function, there are actually many alternatives happening simultaneously. Thus, such supposed weirdness is entirely a product of the wave function itself. In broader terms, then, the quantum theorist or interpreter has no right to say that these many alternatives do not all occur together. In other words, if a theorist shouldn't really say anything about an unobserved realm or a realm beyond the wave function, then what right has he to say that such alternatives don't all occur together, After all, the wave function is as it's put, telling him that they do all occur together. Thus, in order to demonstrate that these alternatives aren't really happening simultaneously, a quantum theorist would need to move beyond the maths and enter the weird and mysterious world of interpretation. In other words, the quantum theorist would need to offer an interpretation of all the mathematics. To change tack a little, the title of this essay is, Does Wigner's Friend Support Consciousness First Physics? So there's a reference to consciousness in that title. Schrödinger's scientific realism, despite the fact that many idealists, New Agers, and spiritual commentators recruit Schrödinger into their various causes, see here and there, stress on Schrödinger's anti-materialism. It's clear that, as far as quantum mechanics itself is concerned, he wasn't an idealist. Indeed, it's also tempting to say that Schrödinger was the exact opposite of an idealist, if that way of putting things even makes sense. But sure, in Schrödinger's private and non-scientific life, perhaps he was an idealist, as well as a spiritual person. In any case, let's go into more detail on this. In basic terms, Schrödinger had a problem with the stress on consciousness, or simply on observation, in the Copenhagen interpretation of quantum mechanics. That was because he argued that the collapse of the wave function, as already stated, is as weird or even weirder than the content of the wave function itself. Was Schrödinger right? Think about this story. The wave function, as well as what it describes, is a certain way, and then a mere observation stops it from being that certain way. So can we now conclude that if this is truly the case, then such an observation literally changes reality? This is the case without the observation or experimenter having any physical impact on the experimental setup. All this means that Schrödinger certainly played down the role of consciousness in quantum mechanics. That's despite what Schrödinger's idealist and spiritual quoters and fans claim or merely hint at. See Note 1. So it can, easily, be argued that Schrödinger was a realist. See scientific realism. Alternatively, and in purely philosophical terms, Schrödinger appears to have been a metaphysical realist, at least on this precise subject. See metaphysical realism and philosophical realism. To explain Schrödinger's scientific realism some more, Schrödinger claimed that nature, or the world, was a certain determinate way before any act of observation. Granted that in this account it's essentially the wave function, or to use Schrödinger's own words, what the wave function says, which is real. Yet the wave function is, after all, supposedly telling us something about the world. Thus, in this instance at least, there are or were multiple mutually contradictory alternatives happening simultaneously. So can all this be solved by arguing that there's a dead cat in our universe and an alive cat, its counterpart, in another universe? Let's now move on from Erwin Schrödinger to Hugh Everett and his many worlds theory. Hugh Everett's Many Worlds and Wigner's Friend. In the foundational Many Worlds text, Relative State Formulation of Quantum Mechanics, 1957, Hugh Everett III actually mentioned what he called the amusing, but extremely hypothetical drama that is Wigner's friend thought experiment. Oddly enough, researchers later found that in an early draft that is earlier than 1957 of this doctoral thesis, Everett discussed the Wigner's friend thought experiment, without mentioning either Wigner or the words Wigner's friend. In other words, this idea was in Everett's mind years before Wigner's 1961-67 paper, Remarks on the Mind-Body Question. In any case, Everett was a student of Wigner, so this means that they must have discussed the Wigner's friend scenario together at some point. Anyway, that's the history. What about the many worlds theory itself? In the many worlds theory, as hinted at earlier, we can make sense of everything Schrödinger said earlier by bringing in other worlds. That is, if we bring in another world, then one cat is alive in that world, and another cat, its counterpart, is dead in our own world, or vice versa. In other words, when the box is opened, we find only a dead cat. And that box opening is equivalent to an observation or the collapse of the wave function. So did Hugh Everett and Eugene Wigner actually differ on this issue. Wigner believed that the consciousness of an observer is responsible for the collapse. of the wave function that is regardless of any references to anyone's friend, etc. Everett, on the other hand, stressed the objectivity and non-perspectival aspects of his many worlds theory. What's more, Everett claimed to have solved the Wigner's friend paradox by bringing in different worlds. It must now be said that Wigner himself didn't believe that a conscious observer can also be in a state of superposition. However, he did acknowledge that this is the end result that is a reductio ad absurdum of his own thought experiment. Indeed, that was his thought experiment's central point. Wigner's actual position, however, was that the wave function had already been collapsed. When his friend observed the cat, or when he observed any given quantum system. Now, if we relate all this specifically to the Wigner's friend scenario, some technical details. Wigner's friend measures, say, the spin of an electron, or the life status of a cat. This results in a branching of the or our world into two parallel worlds. In one world, Wigner's friend has measured the spin to be 1, or the cat to be alive. At another world, the very same friend that is Wigner's friend obtains the measurement outcome 0, or the cat being dead. So what about Wigner and his friend when taken together as a joint quantum system? When Wigner himself measures the combined system of his friend qua system and the electron, spin system or cat system, then that system splits again into two parallel worlds. Now, let's sum up Wigner's friend again. If I collapse the wave function of, say, an electron or a cat, then my friend has to observe me collapsing or offering him information about the electron's or cat's wave function. More relevantly, my friend needs to collapse the wave function that is myself collapsing the electron's or cat's wave function. This is where it gets bizarre. If this is the case, then a friend of my friend will need to observe my own friend in order to collapse his wave function, which is actually now my friend plus myself plus an electron or a cat. In other words, my friend's friend is collapsing the wave function, which is my friend collapsing the electrons or cat's wave function, and that wave function includes myself collapsing the electrons or cat's wave function, and so on. The theoretical physicist Carlo Rovelli puts all the above in both a technical and a philosophical way. Carlo Rovelli on Wigner's friend. In Carlo Rovelli's philosophical system, we have what he calls an observer system, O, which he sees as an epistemic system, which interacts with a quantum system S, which he sees as an ontological system. See Rovelli's relational quantum mechanics. We therefore need to take into account the fact that there are, or at least, there can be different accounts of the very same quantum system. This is a variation on the notion of the underdetermination of theory by evidence. In more technical detail on the wave function and its alternatives. System S is in a superposition of two or more states. A theorist or experimenter can collapse this system to achieve an eigenstate, which is both determinate and circumscribed. All this means that if we have two or more interpretations of System S, then what scientists call observers must have been brought into the story. And that also means that there must be additional relations, or what Rovelli calls interactions, to consider between System S itself and things outside S. In terms specifically of Wigner's friend, this also means, or at least it can mean, that we need a second observer, O, to observe the observer system, O, who, or which, in turn has observed or is observing quantum system S. All this multiplies relations, or interactions, indefinitely. Indeed, perhaps we even have some kind of infinite regress on our hands here. Now, another important part of this story needs to be told. In simple terms, consciousness first theorists dispute the idea that an instrument can, on its own, collapse the wave function. Michio Kaku picks up on this debate. Michio Kaku on observers versus cameras. The physicist Michio Kaku tackles this issue in terms of the specific case of human observers versus cameras. Kaku writes, "Some people who dislike introducing consciousness into physics claim that a camera can make an observation of an electron, hence wave functions can collapse without resorting to conscious beings. Prima facie. Even the phrase a camera can make an observation of an electron seems odd. Indeed, it seems anthropomorphic to claim that a camera, alone, can observe anything. Isn't it the case that human beings use cameras in order to observe things? However, perhaps this is just a semantic issue. See Note 2. In any case, Kaku then raises the following problem. But then who is to say if the camera exists? Another camera is necessary to observe the first camera and collapse its wave function. Then a second camera is necessary to observe the first camera, and a third camera to observe the second camera, ad infinitum. This is a concrete example of the problem of Wigner's friend. Firstly, Kaku's words are about a camera which is supposed to observe a cat or a quantum system all on its own. Kaku also seems to be bringing up the issue of this camera's very existence, as it was before it too was observed. Or, at the very least, Kaku brings up the issue of the camera's wave function, itself being required in order for the cameras to exist. Is this an anti-realist, if not idealist, point about the very nature and role of so far unobserved, as it were, noumena? All that said, isn't it the case that Kaku's camera still registered something regardless of any minds that later made sense of or interpreted that registration? Schrödinger, again, talked in terms of minds giving it meaning. Some readers may question about the word registered. I quibbled earlier about the word observed when it came to Kaku's camera observing all on its own. In this case at least, all registered means is the following. Prior to observation, something left some kind of physical imprint on the camera. Yet it's still the case that what the camera supposedly registered or observed may not have any role to play until what it registered or observed is also registered or observed by another camera. More relevantly, what the camera registered or observed may not have any role to play until it too is interpreted by an actual human mind. Note: 1. Idealists, New Agers, and spiritual